Yo, what's up? What's up, fams? Let's get started today with our warm-up question for today. The question I am posing to you as a group is: when do you think is a realistic timeline for the first humans to land on Mars? So, when do you think we'll see people on Mars? By 2030, by 2050, by 2070, and by 2100? Um, there is obviously a correct answer for this, obviously, because yeah. So I feel like this class is a lot more optimistic than the other classes I've had so far. It's been really interesting. I've had quite a few. I had some classes that were actually kind of pessimistic with when they think we'll send people to Mars. So we'll see what our class thinks about sending people to Mars. Oh, additionally, there's also going to be a graphic organizer to go along with this. I'm gonna link it right now. It's also on Canvas. But yeah, so take your time. Answer when do you think we'll send people to Mars? You can always petition to send me to Mars, in which case you'll never have to see me ever again, which I'm sure some of you will want to do. Aha, aha. Oh God! All right. Well, you have two people here, and I'm like relying on them for like some pity laughs or something like, But you know, like I'm getting silence here. Silence here. I was really hoping for that. I was like, the one thing I was hoping for when I get people here is I get like some pity laughs because like I really rely on those for my self esteem. But I can tell I got a tough crowd today. I gotta up my game, my joke game today. You know, you're laughing super hard. I'm glad. I'm an entertainer by heart. I'm a comedian. I took theater freshman year of high school, and I never forgot it. So I am a natural performer. Teaching is a secondary career. Acting is number one. Yes, obviously. Okay, so our class is actually very optimistic. In terms of when we think humans will be sent to Mars. We have 16 out of 18 people. So if you're one of the two people who haven't voted yet, please do so. I want to know when you think we will send humans to Mars. I personally would love to go to Mars. I would also love to come back for Mars if that was the case. I think sending humans to Mars would be really easy. Unfortunately, that doesn't mean that they'll be alive, and that also doesn't mean that they'll come back. But that's just my 2 cents. Okay, we are 18 out of 19, so we are almost at 100%. If you're that last person who hasn't responded yet, please do so. I want to hear what you think. So overall, this class is very optimistic. I think I don't know if it was fourth period or if it was fifth period, but one of my classes was really pessimistic, really pessimistic. And I was like, oh dang, like what happened to you guys? But this class is probably, I think, by far the most optimistic one. So far, we have 20 out of 21. I don't want to share the results yet. Oh, we are 21 out of 21. Okay, I can do this. Okay, so out of the 21 people, 13 said by 2050, 6 said by 2030, 2 said by 2070, and 0 by 2100. That's actually really impressive. Last period, I think I had 6 people say by 2070, like 5 people by 2100, and only like 3 people by 2030. So this class is much more optimistic. So that's because all of you are going to be future astronauts, because I believe in this. So now, you think that now that we are sort of, well, now that we are sort of done with this warm up, so what we're doing today is we're actually been talking quite a bit about space travel and rocket science and stuff, and you know the challenges of traveling to Mars. So what I want you to do is, so we have a graphic organizer to go with today's lesson, so you can fill out some stuff as we go along. And we are going to be discussing quite a bit about some of the challenges that involve sending people to Mars. So the first thing we're going to look at once you have your graphic organizer open is we are going to look at why we haven't sent any humans to Mars. So in the 1970s, NASA. So in the 1960s, NASA sent I think six successful missions. It's either 6 missions total or 6 successful missions. I don't remember which one it was, but they sent 6 missions, I think, to Mars.
and to the moon, sorry, the moons. And in the 1970s, they had a plan ready to send humans to Mars. However, it's been 50 years since 1970, and we still haven't really sent any humans to Mars, last time I checked. So we haven't really accomplished that goal. And I think there was another interesting poll where if you asked like what, if you asked like, they asked like what 19, people in the 1960s, like what they, when they thought that they would send people to Mars by, I think most of them said that they expected people, we would send someone to Mars by 2100, by 2000, sorry. And so it's 2020 now, and we still aren't really that close. So it is kind of interesting to see how things change and how little things change at the same time. Um, but what I want you to do now is I'm going to put you in your groups, and I want you to discuss some of the obstacles that you think that may have prevented a humane mission to Mars. So in your groups, I want to try to come up with at least 3 major challenges that NASA has to overcome. So what are 3 major challenges that NASA has to overcome to send humans to Mars? So there's a lot of different kind of challenges that you may you may or may not brainstorm. I want you to come up with at least 3, and then when I bring everyone back, I want you to be prepared to share it in the chat. I like to hear what people say. So I'm going to put you in the groups now, and then I will let you come up with 3 challenges that NASA has to overcome in order to send a human mission to Mars. some good discussions on some of the things that people were talking about some of the challenges people discussed. So what I wanted you guys to do is I want to give you guys a couple of minutes to in the chat. Let's give you until 21. So I want you to do is I want you in the chat, I want you to type in some of the challenges that your group came up with in terms of sending people to Mars. And then when I tell you to hit enter, I want to see what people have brainstormed in terms of challenges of sending stuff and people to Mars. So it'll take about 2 minutes or so till the 22, write out some of the challenges that your group came up with in terms of sending people to Mars. Take about another minute or so. Let's quickly jot down some of the challenges that you and your group discussed. And then in about a minute, we hit enter, and then we'll see what you guys think. Take another 10 seconds or so, and in about 10 seconds, I want you to hit enter with whatever your group challenges came up. 5, 4, 3, 2, 1. Hit enter. I want to see what people have to say. What did your groups come up with? What challenge did your group come up with? We got a bunch of ideas so far. Let's keep these ideas going. What did your group come up with in terms of challenges? Alien protection. That's funny. So as you're still typing in your group's challenges, I'm just going to start reading through some of these. Funding the trip to Mars. Mars trips are would be very expensive for a lot of different reasons. And so one of the challenges also, because there's an actual human in the spaceship, you need to have enough fuel to get there and back. Because previously, as you said, we've only sent rovers. And so sending a rover sending just a rover there is very different than sending a person there and back. And when you add people in the spaceship, it adds more weight, and it also requires more supplies to keep them alive. Funding equipment to keep humans alive, the distance supplies won't last the journey. Some of the challenges we discussed were how can you have enough oxygen to survive, and where would you bring your food in to eat? Because there's no food on Mars, so you have to find a way to bring it in. Being able to sustain life and bring everything that is needed in order to survive on Mars. Being able to launch from Earth and land on Mars successfully. Be able to have the right technology to give the astronauts the best chance they have to succeed to complete the journey. Being able to land, I think, is something that a lot of people have actually really not really thought about. Landing on Mars is actually really challenging. I think we'll talk about that, I think, maybe on Friday, but it's actually a lot more complicated than we think. One of the reasons is that Mars is a very thin atmosphere. So a lot of the ways that we might slow things down on Earth just simply wouldn't work on Mars. So that is one challenge of that. Alien protection, alien protection. Oxygen, food, and water. Yes, those are going to be 3 big things to worry about. Probably the big three things to worry about. It's expensive. Yes, funding is very much an issue. The return journey, food and health of humans, the weight of humans affecting spaceships. cost of everything, oxygen, etc. Yeah, so these are all some very big challenges that NASA has to overcome. And honestly, any one of these challenges is probably enough to really deter a human mission to Mars. When you have all these factors together, I think it really makes it challenging to send a human journey to Mars. That being said, our technology has advanced quite a bit. So, I think it will happen at some point in the near future. But yeah. So one of the challenges that I think that you may or may not have thought about is the fact that Mars is extremely far away. How far away is Mars exactly? So this is something we're going to find out. So what I want you to do now is I'm going to put you in a group and I want you to Google how far Mars is from Earth. Then I want you to record a distance in your graphic organizer. However, here's what's going to happen. When you Google the distance from Earth to Mars, Google will give you a big number. And then you will be wanting to just write it down and just say, I am done. The problem is with this is that the distance from Earth to Mars is a lot more complicated than just one number. And so you need to do a little bit of research in order to try to understand what's going on. So what I want you to do is I want you to, when you type in how far is Earth from Mars, I want you to read through like 1 or 2 articles and see and jot down why is it a lot more complicated than just one number. Once you do a little bit of research, then you can write down whatever a number that you feel like best answer this question. But I don't want you to just go type in how far is Earth from Mars and then just copy the big number from Google. And I want you to read through at least 1 or 2 articles because it's a lot more complicated than that. So I'm gonna give you, I don't know, 5 to 10 minutes or so to go through this, see if you guys can figure out how far Earth is from Mars. Again, it's a lot more challenging than just typing it in and getting the number from Google. So I'm gonna put you in your groups now. Okay, so we are going to look at how far Earth is from Mars. So what you probably came up with in your research is when you first Googled how far is Earth from Mars, you probably saw a number like 169 million miles. However, as I told you, that's not exactly the best answer because it's a little bit more complicated than just a number. The reason why it's a little bit more complicated, as some of you probably have noted from your research, what's happening is that Earth and Mars are both orbiting around the sun. And the problem is that both of them are orbiting sort of at different speeds. So one should be going like this, very fast, and the other could be going like this, very slow. And so what happens is that the distance between the two are constantly changing as you're going around the sun. And when you're measuring the distance between them, right, the closest point is when the two are like right next to each other. And the farthest point is when when they're on opposite sides of the sun. So because they're both revolving around the sun constantly, the distance between the two is constantly changing. So just asking Google to give you a number on how far they are away from each other isn't really accurate because the distance is always changing. And so just having one number isn't exactly accurate. So the closest they can be to each other is something like 38 million miles or something. The farthest apart they can be from each other is like 200 something million miles. So that the range is actually quite extreme. Um, for now, you can just write in 169 million miles as the distance between the two, just because that's the number that Google gave you. But it's important to know that the distance is constantly changing, and that because both of them are revolving around the sun. So we're going to use this 169 million miles in order to look at how long it takes to actually go from Earth to Mars. So right now, NASA's big new rocket that they're working on is called SLS. It's called the Space Launch System. It's the biggest rocket NASA has built since the Apollo missions, and it has a top speed of about 24,500 miles per hour. So what I want you to do is I want you to use the distance from Earth to Mars, which I think it's 168, 169 million miles. So I want you to use the distance from Earth to Mars, which is 168, 169 million miles, and I want you to determine how long it takes for this rocket traveling at 24,500 miles an hour to go from Earth to Mars. So how long does it take for this rocket to go from Earth to Mars? I just want you to be very careful of the units. What units are your time going to be measured in? To figure out how long it takes to go from Earth to Mars with this rocket. One thing that you should consider is that in this particular model, we're just saying that Earth and Mars are both stationary. It's just like on Google Maps, nothing's moving, and you're just going from point A to point B. So that's sort of the model we're using. Once you are able to figure out the time it takes to go from Earth to Mars, I want you to discuss the limitations and the drawbacks of using this model, right? So what does this model not account for? Because this model is kind of flawed, as you can tell. So two things: figure out how long it takes to go from Earth to Mars, and then figure out what are some of the issues with using this particular stationary model of Earth and Mars. Okay, I'm going to put you in groups again. Okay, so to quickly go over how we did this. Basically, the idea is if I know if the amount of time it takes for me to go somewhere is my distance divided by my speed. Basically, how fast I'm going times how much time I'm going gives my distance. So with this general idea here, we can take our distance here, which is 160 million. We divide it by our speed, 4,500. And we get a time of roughly 6,010 hours. But minutes. And then so if you convert this to days, you get something like 285 days, which is like roughly 9 to 10 months, which is a pretty long time. And that's just for one way. If we want to go two ways, it's going to be double that. So the question I have for you is what are some of the limitations and drawbacks of using this particular model? So this particular model, this is what we use a stationary model, which basically means that we're treating Mars and Earth as both being stationary objects. We're basically modeling the situation as being Earth and Mars are both stationary, and we're just doing some math here. Now the problem with this is that Earth and Mars are not actually stationary, and so if we're actually launching a trajectory, an object in Earth to Mars, this model will not work very well because we would completely miss. The distance is always changing, and we're not even accounting for the fact that we're both rotating. So if we're using this to launch something, that's not very accurate. Now, however, if we're just using this model to plan for something, and I think we could still get some valuable information from this. So this model tells us that we roughly need to plan for about 1.5 to 2 years worth of food, water, and oxygen and stuff. And so even though this model is very simplistic, we can still use it to get some information. However, we wouldn't want to use this model for more advanced stuff, such as actually launching something from here to Earth, from here to Mars. So this is something that you do a lot in science sometimes, is you have different ways of modeling different kinds of situations. Some models are going to be more advanced than others, and usually when they're more advanced, they're more accurate. The problem with more advanced models is that they sometimes don't necessarily fit the purpose very well. We could use the more advanced rotation model for Earth and Mars. They're both revolving and rotating around the sun. But we don't really need to use that if we're just trying to plan for a general idea of how much food we need to bring. And that's a little bit too much work. So this is just to introduce you the idea of you can model a situation with different kinds of models, and each model has its own drawbacks and benefits of using it. So some models are going to be easier, but they're not going to be as accurate. Some models are harder, they may be more accurate, but you may not always need to go through that much work. That's just to give you a general idea of what this means by using a stationary model, which is model both of these as a stationary object. A good example of when we might use more advanced models or a more realistic way of examining models is right now, when we look at gravity, we currently look at gravity as being like a force. Like I throw something up and gravity's pulling it down. So that's sort of what we see in our daily lives. And for most math, even for sending stuff to the moon and to Mars, that's the kind of theory you can actually work with. And it's very practical. However, in actuality, the most scientifically accurate theory of gravity is the theory of general relativity, which you may or may not have heard of. But let me put it this way, relativity is very complicated, very complicated. And it's more accurate than more straight down, like gravity is a force, it pulls things together. However, for most of our daily lives, we don't need to use the crazy advanced theory. It's like algebra is like a more advanced version of like addition, essentially, right? I don't know if that's the best metaphor, but like a lot of times you can just use addition. You don't necessarily need to use algebra. But there are times when you need to use algebra because it's more accurate, it's more advanced. So that's the same idea here. Sometimes be more basic models, sometimes be more advanced ones. Yeah. So that's the general idea here. The last thing what I want you to look at here is I want you to look at introduce the second challenge that we have to deal with space travel is it's hard to make things go fast. So what I want you to do is I want you to think about with your groups, do you think it's harder for something to accelerate from 0 to 50 miles per hour? Or do you think it's harder for something to accelerate from 50 to 100 miles an hour? Or do you think that it's potentially the same? So now, and why do you think that way? So is it hard to go something from slow to medium, or is it hard to go something from medium to fast? So in your groups, discuss that and see if we can come up with some ideas on why you think it's easier to go from 0 to 50, or whether or not it's easier to go from 50 to 100. So I'm going to put you back in your groups again. So we're out of time here. So let me wrap up real quick. So we're gonna continue this